Ladies and gentlemen, welcome back to Context Aware. Today, we're about to dive headfirst into the world of science and technology, where the ordinary becomes extraordinary. Picture this: MIT physicists have done what alchemists could only dream of. They've turned graphite, yes, plain old pencil lead, into something that's practically worth its weight in gold. But this isn't some Harry Potter magic trick. It's real science, and it's absolutely mind-blowing. You see, MIT postdoc Zhenguang Liu, assistant professor Long Zhu, and graduate student Tonghang Han have teamed up to take us on a wild ride through the world of mysterious science. And they've just published their findings in the prestigious Nature Nanotechnology. But what's the big deal, you ask? Well, it turns out they've discovered something that could change the game completely. Graphite, that humble stuff you find in your everyday pencil, is actually composed of something called graphene, a single layer of carbon atoms that looks like a honeycomb. Now, graphene has been all the rage in scientific circles for about 2 decades, ever since someone managed to isolate it. But just when you thought they'd squeezed all the juice out of this lemon, these MIT scientists come along and say, "Hold my Bunsen burner." About 5 years ago, researchers, including the folks at MIT, stumbled upon a little trick with graphene. They found that if you stack individual sheets of it and give them a slight twist, you get some seriously funky properties. Think superconductivity and magnetism. They even gave it a fancy name, twistronics. But in this new study, our MIT heroes said, why twist when you can stack? They discovered that stacking 5 layers of graphene in a particular order allows electrons to have a good old chinwag inside the material. That's right, electrons having a chat sounds like a science fiction novel, doesn't it? This electron gossip, also known as electron correlation, is the secret sauce behind all the mind-blowing properties they uncovered. But wait, there's more. Our MIT team didn't stop there. They built a cutting-edge microscope that can examine materials at the teeny-tiny nanoscale. It's like having a magnifying glass that can see the world's tiniest secrets. With this microscope, they hunted for the exact stacking order they needed, known as rhombohedral stacking. There are more than 10 possible ways to stack 5 layers, but they found the one they were after. To study this newfound material, they sandwiched it between layers of boron nitride, creating a kind of graphene sandwich. They added electrodes to the mix, and here's where the magic happened. By tinkering with the voltage, they uncovered not 1, not 2, but 3 different phenomena. It's like they stumbled upon Aladdin's cave of wonders. The material could be insulating, magnetic, or even topological. Now, that last one might sound like something out of a sci-fi flick, but it's the real deal. A topological material allows electrons to zoom around the edges like a race car on a track, but not through the middle. The edges are like a superhighway for electrons, while the center is an insulator. It's like having a secret lane for electrons to zip around while the rest is stuck in traffic. So, what's the bottom line? Our MIT heroes have turned humble pencil lead into a goldmine of scientific possibilities. They've shown us that there's more to graphite than meets the eye, and it's like discovering a treasure trove of new physics. This breakthrough could open up a world of possibilities for technology we can't even imagine yet. But here's the real kicker. Why did we never realize that all these fantastic properties were hidden within something as ordinary as graphite? Nature has a way of surprising us, and it makes you wonder what other secrets are out there waiting to be uncovered. The world of science and technology is full of mysteries, and it's up to us to keep digging, keep exploring, and keep asking questions. So, my fellow science enthusiasts, what do you think the next big discovery will be? What other hidden gems are waiting to be found in the world of mysterious science and technology? Let's keep the conversation going, and until next time, stay curious,